Hi, welcome to Algebra 2 Common Core. Today we're going to be covering the topic of factoring completely. To factor completely means that we're going to take our expression and we're going to write it as a product, which includes polynomials that contain no greatest common factor. Let's take a look first of all at that word product. Product means that all of the factors in our answer will be multiplied together. Polynomials can include monomials, binomials, or trinomials, and we'll want these polynomials to have no greatest common factor. So the steps that we will be following for completely factoring would be, first of all, to look for a greatest common factor that I can factor from all of the terms in my original expression. If I can factor out that GCF, I do so first. If not, then I look at the next step, and even if I've already factored out a GCF, I look at the next step. I want to find polynomials that can be factored using one of the methods that we've talked about so far. So those methods could include difference of two perfect squares, or I might have a trinomial that needs to be factored. Or possibly I might have either the difference or the sum of two cubes. So let's go ahead and try some examples of factoring completely. So in exercise number 1, I have 4x squared plus 12x minus 40. I see that I can factor a 4 from all three of those terms. So dividing each term by 4, I now have x squared plus 3x minus 10. But I don't want to stop there because I notice that that polynomial can be factored. It's a trinomial. So remember how we did our trinomials? We are looking for two numbers that add to give me 3 and multiply to give me negative 10. So I keep the 4 as my GCF in front of my answer, and I'm going to write two binomials multiplied together. To get x squared, I have to multiply x times x. And when I think about the combination, I see that I want to have a 5 and a 2, so that 5 times 2 is 10, and 5 plus 2, well, actually I'm going to make one of them negative, so we're going to say a positive 5 and a negative 2. When I look at all of the factors in my answer, I see that none of them can be factored any further, so that tells me that this is my polynomial or my expression in completely factored form. Let's try part B. For B, I'm just going to write it down here where I have more room. I am starting with 6x squared minus 24. So I see that there's a GCF, a greatest common factor of 6. Factor that out, and that will leave me with x squared minus 4. But x squared minus 4 is the difference of two perfect squares, so I'm going to factor that as x plus 2 times x minus 2. And again, when I look at my answer, I see that there are no polynomials that can be factored any further, so that's my final answer. Let's go to part C, 2x squared plus 20x plus 50. I see that all three of the terms can be divided by 2. So when I factor out the GCF of 2, I'll have x squared plus 10x plus 25. Now if we examine that closely, we see that we have a trinomial. So let's try to factor that by adding to get 10 and multiplying to get 25. Keep the 2 out in front. And as my two binomials, I'm going to multiply x plus 5 times x plus 5. Let's finish with example D, where we see that we have a GCF of 3. I'll still have 25 minus x squared left over. That, of course, is the difference of two perfect squares. So I'm going to keep my 3. Now be really careful with the order here. When I factor the difference of two squares to get the 25, that's going to be 5 times 5, and I write those down first. To get minus x squared, I'll have a positive x and a negative x. So here's my final answer in completely factored form. Now those were a good challenge, but let's keep going and see the next 4, which are going to require a little bit more thought when we have to completely factor. Continuing on with exercise number 2, let's look at part A. 10x squared plus 55x minus 105. I notice that yes, we can take out a GCF, and I think the biggest term that can come out, the biggest factor, is a 5. So when I divide everything by 5, I now have 2x squared plus 11x minus 21. Now I have a trinomial, but it's got a number other than 1 in front of the x squared. So you know me, I love my box factoring, so I'm going to multiply and say I need to have two numbers that multiply to give me 2 times negative 21, which is negative 42. But I have to add to get that middle number, which is 11. So I'm looking for two numbers that add to negative 42 and multiply to 11. If I try out all my factors of 42, I think the combination that's going to work correctly is positive 14 and negative 3. Remember to put an x with both of them. Now I'm going to just make my box over here. Now inside the box, I'm focusing on this trinomial, not my original one. So I've got a 2x squared, I've got a negative 21, and then I'm going to use the 14x and the negative 3x as the other two entries in the box. So let's look for a GCF on the top row. That, of course, is going to be 2x. Bottom row, I'm going to take a negative 3 out of both of them. First column, I see that I'm going to take out an x. And for the second column, I see that I'm going to take out a 7. So my final factors for this one are going to be 5, that was the GCF, times what I got when I did the box, x plus 7 times 2x minus 3. And my last step is to look at all of those factors and make sure there's nothing that I can factor further. Moving on to B, I've got 12x squared plus 57x minus 15. So for this one, I'm going to factor out a GCF of 3, and I'll have left 4x squared plus 19x minus 5. Now my job is to look for, again I see I've got a trinomial that doesn't have a 1 in front of the x squared. So I want to multiply to get the product of 4 and negative 5, which is negative 20. But I want to add to get that middle term, which is 19. So let's go right to our box here. So I see that I'm going to have a 4x squared, a negative 5, and the combination that correctly adds to 19 and multiplies to negative 20 is going to be a positive 20x and a negative 1x. So from my first row, I'm going to take out a 4x. Second row, negative 1. First column, x. Second column, 5. So my factors for this one, 3 times x plus 5 times 4x minus 1. And I, of course, am getting those binomials from here and from here. So there's my completely factored form of that trinomial. Let's do one more together and then I'll let you do the last one on your own. So for part C, I notice that I'm going to take out a GCF of 6. So I now have a 4x squared plus a 6x minus 3. That means that I want to multiply to get negative 12, add to get 6, I think I divided that wrong. Let's try that again. So going back, my GCF was 6, so I had left 4x squared. It should be a 4x in the middle, minus 3. So now I want to multiply to get negative 12, add to get 4. So that combination has to be a 6 and a negative 2. So go ahead and make your box. I got to kind of fit it in here, so it's going to be little. 4x squared, 6x, negative 2x, and negative 3. So for my top row, I'm going to factor out a 2x. Bottom row, negative 1. First column, 2x. Second column, 3. So my factors, 6 times 2x plus 3 times 2x minus 1. There are my factors. Please take a few minutes to do exercise 2, part D, and then come back and check your answer with mine. Well, I got the final answer 2 times 3x minus 2 times x plus 6. My GCF was 2, so that left me with 3x squared plus 16x minus 12. I saw that I had to multiply to get negative 36 and add to get 16. So the combination that worked for me was a positive 18x and a negative 2x. So from my first row, I factored out a 3x. From my second row, I factored out a negative 2. So there's my factor 3x minus 2. From the first column, I factored out the x. From the second column, I factored out a 6. So there's my factor x plus 6. For exercise 3, we have a little bit more of a challenge with each of these problems. So let's look at part A together. 45xy squared plus 15xy minus 10x. Do you notice that we have a GCF in this case, not only just the number 5, but I can also take an x out of all of the terms. So when I factor out a 5x, I'm going to be left with 9y squared plus 3y minus 2. Now, you'll notice that the variables are different, but that's okay. My GCF had an x in it, but I factored all the x's out. So now the trinomial has just y's. So let's go ahead and do this as a box method because I've got a coefficient in front of my squared term. So that tells me that I want to multiply to get negative 18, but I want to add to get that coefficient in the middle, 3. So my combination should be positive 6 and negative 3. We're putting y's with each of those because this trinomial has y's in it. So let's go ahead and do the box for that trinomial. So I've got 9y squared, 6y, negative 3y, and negative 2. From my first row, I'm going to take out a 3y. From the second row, a negative 1. First column, 3y. Second column, 2. So here are my factors. 5x multiplied by 3y minus 1 times 3y plus 2. And again, looking at all of the factors in my answer, none of them can be factored any further. Now, looking at part B, I notice that I don't have a GCF this time. So when I look at this factoring, I'm going to view it as just a trinomial. So I'm going to say, let's find two numbers that add to give me 3 and multiply to give me negative 40. Now when I go to my parentheses, though, I'm going to have to say that my product has to be y to the 6th. So I'm going to put y to the 3rd times y to the 3rd. Now if I have to add to get 3 and multiply to get negative 40, I know that the combination would have to be an 8 and a 5, with the 8 being positive and the 5 negative. So that was a little bit trickier factoring to begin with. But now as I look at this closely, I see that I have the sum of two perfect cubes. So I need to factor that now. Remember how we did two cubes? We said let's take the cube roots and keep the sign the same. So y plus 2. Then for my second factor, this is going to be the first thing squared, so y squared. Opposite sign, so negative 2 times y. Last term squared, so plus 4. So my final answer, the y cubed plus 8 is factored into this, but then I still have to multiply by y cubed minus 5. So my final answer in completely factored form would be this. Let's go ahead and finish the last one. I'm just going to move down here so I have enough room. 16x to the 4th minus 1. Again, there's no GCF, so I look at this and I say, I think we have the difference of two perfect squares. So that means I'm going to factor it into two binomials. To get 16x to the 4th, that's going to be 4x squared times 4x squared. To get a negative 1, I'm going to use positive 1 times negative 1. Now as my last step, I noticed that this binomial can be factored further because it's the difference of two perfect squares. So my first factor cannot be factored because that's the sum of two squares, so we don't have a method for doing that one. But 4x squared minus 1 is the difference of two perfect squares. So we're going to say 4x squared is going to be a 2x times a 2x. And negative 1 will be a positive 1 times a negative 1. And again, I can't stress it enough. I cannot factor the sum of two squares. I can only factor the difference of two squares. So my final answer in factored form looks like this. Look over all of these examples that we've done. In class, we're going to practice a lot more with factoring using all of the techniques that we've covered so far in this unit. Have a great night, and thanks for working on factoring with me today. Bye-bye.